mechanical generator, mechanical energy is first converted into magnetic energy, and then the magnetic energy is converted into the electrical energy. The magnetic energy is a medium through which energy conversion takes place. When mechanical energy is supplied to the generator, there is a tendency of magnetic energy to increase, but the magnetic energy has got inertia to change. Since the magnetic energy has got inertia to change, electrons in the coil flow to one end of the coil, making it negatively charged. Since the other end is devoid of electrons, it becomes positively charged. Hence, electrostatic energy is produced at the coil ends. Thus, the change in the magnetic energy is converted into electrostatic energy. By equating change in magnetic energy to the electrostatic energy, Faraday's laws of electromagnetic induction are derived. When we bring a magnetic needle near a magnet, it rotates and aligns with the field line. This means that a potential energy is present near a magnet. This energy is called magnetic energy. Though the magnetic flux and the magnetic energy are related, they have got different units. The magnetic energy is expressed in joules and magnetic flux is expressed in joules per current. Let the magnetic flux is linking the stator coil. Let's denote the energy present by mag energy. The mechanical energy is supplied to the generator in a time interval delta t. Magnetic energy tends to increase. Let us denote the increase in a magnetic energy by delta mag energy. But magnetic energy has got inertia to change. Where is increase in the magnetic energy gone? It is converted into kinetic energy owing to the flow of electrons. Electrons flow from one end to the other end of the coil. That is, the current is induced which flows in a opposite direction. The electrons collect at one end of the coil, making it negatively charged. Since the other end has become devoid of electrons, it becomes positively charged. Hence, an electrostatic energy is produced at the coil ends. Thus, the kinetic energy due to the flow of electrons is converted into electrostatic energy. The EMF is equal to electrostatic energy divided by charge Q. Thus, the varying magnetic field has induced an EMF at the coil ends. This is what the Faraday's first law of electromagnetic induction states. It states that a varying magnetic field induces an EMF in a conductor, and when the circuit is closed, an induced current flows through it. We have seen that a change in magnetic energy is converted into kinetic energy. The kinetic energy is converted into electrostatic energy at the coil ends. Thus, delta mag energy is equal to electrostatic energy. Let us divide both sides by charge Q. Hence, EMF is equal to delta mag energy divided by Q. Let us multiply numerator and denominator by delta T. Q is equal to A delta T. That is, delta T by Q is equal to 1 by A. Hence, EMF is equal to delta Mach energy divided by A delta T. Flux is equal to magnetic energy divided by current A. Therefore, EMF is equal to delta phi by delta T. As time approaches zero, delta T becomes equal to dt. Hence, EMF is equal to d phi by dt. Suppose the number of turns are doubled. Charge in each turn is equal to q by 2. The charge at the coil end is equal to q, the same as in a single turn coil. And electrostatic energy is same as in a single turn coil. EMF at the end of the turn is equal to electrostatic energy divided by q by 2. Hence EMF is doubled. This is applicable for n number of turns. Hence EMF is equal to n d phi by dt. Or EMF is equal to d n phi by dt, where n phi is a flux linkage. Thus EMF is equal to rate of change of flux linkage. Hence Faraday's second law of electromagnetic induction is derived. The Faraday's second law of electromagnetic induction states that the induced EMF is equal to the rate of change of the flux linkage. Thus, we have derived the Faraday's laws by equating the change in magnetic energy to the electrostatic energy.